Hello, this video is going to be all about how to deduce the number of protons, neutrons and electrons in an atom or an ion. So we'll start with atoms. We'll look at fluorine first of all. So fluorine, if you've got a periodic table with you, you'll be able to see something that looks like this. Fluorine has two numbers, and you may have slightly different values for these numbers. So it might be slightly different to what I've got here. I'm using very simple versions of the numbers. This is known as the mass number up here. And down here we've got the atomic number. It may, on your periodic table, call this the proton number. It may even, on the periodic table, have it the other way around. The 19 might be at the bottom and the 9 might be on top. Makes absolutely no difference. Now, the atomic number is sometimes known as the proton number because it tells us the number of protons. So, in fluorine, we have 9 protons. Now, the mass number is the number of protons plus the number of neutrons. So we've got 19 overall. We know we have 9 protons. So to work out the number of neutrons, we just do 19, take away 9. So our neutrons are 10. To work out the number of electrons, in an atom, they're always going to be the same as the number of protons. And the reason for this is atoms have what we call zero charge. So up here on ions, you'll see either a 1 minus or a 2 plus or a 1 plus or something that states what charge it has. If there's nothing there, so if it doesn't tell you whether it has a charge or not, then it must be 0 or no charge. If I just create a little table up here, protons have a +1 charge, neutrons, clues in the name, it's neutral, so it has no charge, and electrons have a -1 charge. So if we've got 9 protons, put along here, 9 positive charges, then we must have 9 electrons to cancel every one of these protons out. So up here, if it's going to be 0 or no charge, there can't be any more positives than there are negatives, there can't be more negatives than there are positives. So because we've got 9 protons, we must also have 9 electrons. So this is, from looking at this fluorine, we're looking at the atomic number, the mass number, and the charge. All atoms have 0 charge, and we'll have a look at another atom in just a sec. We can work out from that information how many protons, neutrons, and electrons there are. So this time we'll have a look at argon. So do you remember what this number is called? The mass number. And this number down here? The atomic number. So the atomic number, you may have called it the proton number, tells us the number of protons. So in argon, we have 18 protons. Now, if you come across an element and it's got 18 protons, it can only be argon. The proton number or atomic number tells us what element we have. And if you have a look at the periodic table, you'll see every single element on there has a different atomic number, and it actually goes in order. If you read across, hydrogen starts with 1, helium has an atomic number of 2, lithium of 3, and so on and so forth. Argon, therefore 18. Its neutrons, we've got 40 for a mass number, so 40 minus 18 gives us 22. And then our electrons, there's no charge up here, so our electrons equal our protons. They cancel each other out. So we have 18 electrons there. And that is how we work out the number of protons, neutrons and electrons in an atom. Next up, we'll have a look at ions. If you want to give this a bit of a practice before looking at ions, stop the video now. There's some practice questions just attached with answers. You can give them a bit of a go and then move on to the ions. So, ions are different. If we draw up here just a few examples of ions. So, you may have seen Ca2 plus, F minus, Cl minus, S2 minus, Al3 plus. They've all got this charge written on them. And we'll take an example. If we bring down calcium, 2 plus, just rub those out. Calcium 2 plus has a mass number of 40 and an atomic number of 20. So we can straight away, we can do our number of protons, have 20 of them. We know it's calcium, so it must have 20 protons. Number of neutrons, let's do that. We take the mass number minus this number, the atomic number, to give us 20. Now the tricky bit is now to work out the number of electrons. And the number of electrons in an ion is different to the number of electrons, how to work out the number of electrons in an atom. These now aren't even. What's happened is calcium's reacted. It's either, in this case, given away some electrons, but it could gain some electrons. And that's changed the charge on it. The number of electrons that orbit around this calcium is now different. Now the 2 plus lets us know exactly how many electrons it has lost. It's now got essentially 2 more positive charges than it does negative charges. So we have a look at this, we know it's 2 plus, we know we had 20 protons, so we must have 18 electrons. Each proton gives a positive charge. So there's our 20 protons, all given a positive charge. Electrons are going to cancel that out with a negative charge, but we know we need, overall, we're going to have 2 positives left over. So 2 positives. All the other protons are going to be cancelled out by electrons. So if all the other are cancelled out by electrons, leaving 2 left over, we must have 18 negative charges here to cancel out that 2 positive. I'll look at fluorine again. Now when fluorine becomes an ion, comes fluoride. Now you may see it written as just a single negative. So if you just see a negative there, that just means -1. Just to make it easy, I'm going to say it's 1 minus, but you may see it without that 1. You may even see it as -1 with a 1 coming after the negative symbol. Makes no difference. So we saw earlier, it's got mass number of 19, proton number of 9. So if we're working out the number of protons, neutrons or electrons, protons doesn't change. Still although it's an ion now, it's still fluorine or fluoride. It's got 9 protons. Neutrons, 19 minus 9 gives us 10. Now electrons, this time it's got a negative charge, so it must have more electrons than it has protons. And it's -1, so it must be 1 more. If we put down our 9 protons, then we know it's not positive, so they're all going to get cancelled out, and we need one more to get overall a -1 charge. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 electrons then in our fluoride ion. So that is how to deduce the number of protons, neutrons and electrons in ions. So the tricky bit is when we go into our ions and determine the number of electrons in an ion. So if you want some practice on that, again, there's some questions on the worksheet and answers provided as well. Good luck.